Hi everyone. So here we have a question that reads, a medical researcher proposes to estimate the mean serum cholesterol level of a certain population of middle-aged men based on a random sample of the population. He asks a statistician for advice. The ensuing discussion reveals that the researcher wants to estimate the population mean to within plus or minus 6 milligrams per dl or less, with 95% confidence. Also, the researcher believes that the standard deviation of serum cholesterol in the population is probably about 40 milligrams per dl. How large a sample does the researcher need to take? To start off, we first highlight the important facts from the question. So I can see here that the researcher wants to estimate the population mean to within plus or minus 6 milligrams or less, and he or she wants to be 95% confident, and the researcher estimates that the standard deviation of serum cholesterol in the population is about 40 milligrams. Now the question is asking, how large a sample does the researcher need to take? So the question is asking for us to calculate the sample size. So let's start off by writing up all the information that we highlighted. So the mean to within plus or minus 6, which is this piece of information here. So we know that that's the margin of error. So margin of error, which I can denote by ME, is given by 6 milligrams per dl. And the second piece of information that we know is the confidence level, which is going to be 95% or 0.95. The third piece of information we know is the standard deviation. So that's the population standard deviation. Population standard deviation, which is represented by sigma, to be 40 milligrams per dl. And it is asking for us to calculate the sample size, which is n. Now, to calculate the sample size to estimate the mean, the formula is given by sample size n equals, it's going to be z of alpha over 2 over margin of error, write it again, z of alpha over 2 over margin of error times sigma, all of it squared. So essentially we have the sigma here, which is 40, we know. We also have the margin of error, which is 6, but we just need to calculate z of alpha. We just need to find z of alpha over 2. So let's see how we can find that. So we need to find z of alpha over 2. And alpha is given by 1 minus the confidence level. So that's going to be 1 minus 0.95, which is 0.05. And if I want to do alpha over 2, that's going to be 0.05 over 2, and that's 0.025. So now we're going to go to the table and find 0.025, find the corresponding z-score for a probability of 0.025. So if I look at the table here, I can zoom in a little, and then I can see there's 0.025 here. So the corresponding z-score for that is going to be negative 1.9 and 6. So you can go back. So you found that our z value, so z of alpha over 2 was negative 1.96. So now it's just putting it into the formula for sample size. So this is going to be, now I can take the negative or not, but because I'm going to square it anyways, so the negative is going to go away. So I'll just write 1.96 over margin of error, which was 6, times sigma, all of it squared. So if I calculate that, 1.96 times 40 over 6, all squared. So I get n of 170.74. Now because n is a sample size, that is the number of subjects in the study, it cannot be a decimal. So for n, we always round up. So we can say n is going to be a minimum of 171. So here, the final answer is that the required sample size is at least 171.